Hello everyone and welcome back. In the first video that we recorded with this topic, exponents and powers, we basically started with some very important stuff. We introduced our first rules that we actually apply every time when we deal with exponents and powers. So the first rule that we introduced is if we multiply two numbers that have the same base, then what we do is we just copy the base and we add the exponents. Another rule that we introduced was if we divide two numbers that have the same exponent, what we do is basically we copy the base and then we subtract the exponents. Finally, the third rule we introduced was if we have a number raised to a certain power and then we have another power on top of it, then that means that we just have to multiply the powers, to multiply the exponents. All right. Let us see some actual examples so that we can actually practice this topic. So if we have here 5 to the power of 4, for example, multiplied by 5 to the power of 10, what did we just say? We keep 5 and then we add the exponents. So 4 added with 10 will be equal to 14. So the final answer is 5 to the power of 14. Now my students sometimes ask me, oh, but do we have to find the actual value of 5 to the power of 14? No, we leave it in this form. Sometimes in your exam questions you will see that the question says, write this in index form. This is what they mean basically by index form. That's it, we are done. Then we have question 2. 5 to the power of 14 divided by 5 to the power of 10. We said if it's division, the only thing we need to do is to subtract the exponents. So 14 minus 10 will be equal to 4. That's it, we are done. The final example is 5 to the power of 2 and then to the power of 3. So we said here, if we have double powers, we copy 5 and then we multiply the exponents. So 2 multiplied by 3 will be 5 to the power of 6. All right, now that we revised this, I just wanted to remind you two very important things. If we raise a number to the power of 1, then the final answer will always be the number itself. So when it's, for example, 5 to the power of 1, it will be 5 only, and that's it. Or if we have 5 to the power of 0, the answer will always be 1. Now guys, in the new topic, now we don't play with numbers only, but with variables as well. So if we have, for example, a to the power of 8, then we multiply that by a to the power of 4. We apply the same rules that we already know. So it will be a, and then we add the exponents. So it will be 8 plus 4, which is basically equal to a to the power of 12. All right, if we have, let's say, division, a to the power of 12 divided by a to the power of 7, let's say, this will be a to the power of 12 minus 7, which is equal to 5. So the answer will be a to the power of 5. Now, there is something where my students struggle a lot, and that is if we now combine numbers with variables. So if we say, for example, let's say 2a to the power of 4, we multiply this by 5a to the power of 3. The rule is number by number, variable by variable. So basically, in this case, we have 2 multiplied by 5, which is equal to 10. And then we have a to the power of 4 and a to the power of 3, which is equal to, we said we add the exponents over here, so that will be equal to a to the power of 7. That's it, we have the answer. Okay, let's try to combine them again. If we say, for example, 15 x squared y to the power of 8 divided by 5x y to the power of 3. So we said number by number, variable by variable. If we say number by number, then what we do first is 15 divided by 5, which is equal to, excellent, that is equal to 3. Then we have x squared divided by x. We said when there is no exponent, we consider that there is 1. 2 minus 1 will be 1. So it's x to the power of 1, which is x. Then finally we have y to the power of 8 divided by y to the power of 3. If we minus 8 minus 3, that will give us y to the power of 5. So our final answer is 3x y to the power of 5. Alright, we hope that this is clear. Let's try something else now. If we have, for example, x to the power of 2 and then to the power of 3, we all know that this is equal to x to the power of, and then we multiply 2 by 3, which is x to the power of 6. We all find it pretty easy. But what if we add multiple things in the brackets, not only x squared? What if we say, for example, 3x squared y, and then we say everything to the power of 2? Alright, let us try it together. What is 3 to the power of 2? I hope that we know the answer. It is 9. Then we have x to the power of 2 to the power of 2. Let me write it for the first time. X to the power of 2, but then again to the power of 2. Finally, the last one is y and then to the power of 2. So we have raised all of them to the power of 2. Alright, let's see what we get then. 9 remains the same. X squared to the power of 2, we multiply the exponents, so x to the power of 4. And finally, y to the power of 2. That's it. We have the final answer. Alright. What happens if we have, let's say, a to the power of 6 and then everything to the power of 2b? No problem, because we know that if we have our base and then double exponents, 6 and 2b, what we do is we multiply our exponents. But we know that 6 multiplied by 2b is equal to 6 multiplied by 2 is equal to 12, and then we have b. So the answer is a to the power of 12b. Let's have even more difficult examples. So if we try with 3x to the power of 3, and then we add y to that, we multiply that by 4xy to the power of 2, and then we divide everything by 3x to the power of 2 y. All right. Let's play with this together. We know that our priority is to simplify the numerator first, which means we need to multiply them first. So we said number by number, 3 times 4, which is equal to 12. Then we have x cubed by x, which is x to the power of 4. Then we have y and y squared, which is y to the power of 3. In our denominator we have 3 to the power of 2, which is 9. Then we have x to the power of 2. So we copy that, x to the power of 2, and we have y. In our final step, number by number, variable by variable. So basically 12 and 9, we cannot divide them, right? But can we simplify them? Yes. So both 12 and 9 can be simplified by 3. So 12 divided by 3 is equal to 4. 9 divided by 3 is equal to 3. Then we have x to the power of 4 divided by x to the power of 2. Remember, we subtract the exponents. So 4 minus 2 is 2. Finally, y to the power of 3 divided by y, which is y to the power of 1, is equal to y to the power of 2. That's it. We have our another answer. Alright, let's play with the two rules that we basically introduced today. So, if we say, for example, 4 over 5, and then everything to the power of 2. The way we solve this is, first of all, what do we have in the numerator? 4 to the power of 2. And then in our denominator we have 5 to the power of 2. So 4 to the power of 2 and 5 to the power of 2. 4 to the power of 2, 16. 5 to the power of 2 is 25. So basically, if we have a fraction to raise to a certain power, then both numerator and denominator will be raised to the same power. Alright, let's have an example of it. So, if we have, let's say, 2a squared over 3b to the power of 3, and then everything raised to the second power. So guys, we said, if we have both numerator and denominator to the power of 2, we split them now. So we have 2a squared to the power of 2, and then we have 3b cubed to the power of 2. Alright, we are almost done now. In the numerator we have what? 2 to the power of 2? 4. A squared to the power of 2? A to the power of 4. And then our denominator, 3 to the power of 2? 9. B cubed to the power of 2? B to the power of 6. There is nothing we can simplify over here, so we can say that this is our final answer. Alright, let's have a few more examples. So if we say, let's say, x to the power of 3, and then we have 4y, and then everything to the power of 2. I will give you a minute. Try to do it yourself. Alright guys, I hope that you pause the video to complete this. Now, we will solve it together on the board on the screen. In case we get the same answer, please write it down in the comment section. If we do not get the same thing, let me know if you have any questions so that I can help you in the comment section. So, let's start. X to the power of 3 is our numerator. So we say x to the power of 3, we raise it to the power of 2. Then our denominator is 4y, and then we raise that to the power of 2. In our numerator we have x to the power of 3 times 2 will be 6. So we can fix our mistake, and that is alright. We all make mistakes. 3 multiplied by 2 is 6. Our denominator, 4 to the power of 2, 16. Y to the power of 2 is y squared. Is there anything that we can simplify here? I wouldn't say so. That's it. We are done with this question. Let's have two more questions, and with that, today's lesson will be over. So, our first question is 2 over x squared y, and then everything to the power of 4. And there is another one, 3x squared y cubed over 4z, and then everything to the power of 2. Again, same as before, try to pause the video and to solve these two questions by yourself. In case you need any help, let me know in the comments. I'll do my best to help you. In case we get the same answer, also let me know so that I can know that you understood the lesson completely today. All right, let us start with the first one. If you pause the video and had enough time to complete it, we check the answers together. First of all, we have 2 to the power of 4, no problem. Then in the denominator we have x squared y, but then everything to the power of 4. In our numerator, 2 to the power of 4, we can solve it. 2 to the power of 4 is 16, or you can keep it as 2 to the power of 4. That would be correct as well. Our denominator, x to the power of 2, and then to the power of 4, multiply the exponents, x to the power of 8. Y to the power of 4 will be y to the power of 4. Perfect. One last question for today. Let's choose blue color this time. So, both our numerator and denominator will be raised to the power of 2. So we have 3x squared y cubed to the power of 2 over 4z to the power of 2. Finally, what do we get here? 3 to the power of 2, 9. X squared to the power of 2, x to the power of 4. Y cubed to the power of 2, y to the power of 6. Perfect. Our denominator, 4 to the power of 2, 16. Z to the power of 2 will be z to the power of 2. That's it. We have the final answer. So guys, that would be enough for today. I hope that we understood everything. Please let me know in the comment section if you have any questions about me. Ask your teachers if you have any doubts, any questions, or you can email me at any time. In the description box, you can also find PDFs with lots of examples, practice and solved questions so that you can actually do the practice by yourself. See you next time. The lesson for the next video is exponents and powers with negative exponents. That's it for today. See you next time.